this is the University of St. LaSalle College of Arts and Sciences Mathematics Department. We will have this series of video lectures we call Algebra 101. So these videos will simply capture the basics of the subject, hence the 101 title. Take note that these are video lectures. You may think of these as lecture notes only in video format. So there will be more content than exercises, but we'll provide examples, of course. What we'll talk about now is one selected topic, which we call functions. Okay, so let's get into it. So in this video, we will recognize and represent relationships between quantities through functions. So first up, we'll start with definitions. Definitions that will lead us to functions in the end. So first in our definitions list is relation. So a relation is any set of ordered pairs, x and y. Okay, that is a set. Okay, any set of ordered pairs, simply x and y. So for example, we have this 1 5 2 6 3 7 4 8. So this is an ordered pair 1 5. This is another pair 2 6. This is another pair 3 7. This is another pair 4 8. Okay, imagine our x as our first component. Imagine our y's as our second components. You can think of x as our input values, y is the output value. Okay, so this is a relation. So it's a set of ordered pairs. Next up in our definitions, we will define a domain. So a domain is a set of permissible input values of x. So imagine our x's in this particular example here. If we're going to put it in a set, we call it a domain. Okay, the set of input values, all the x's. Third is the range, the set of output values y. So again, if we're going to put all the y's in this particular example here, put it in a set, we call it the range. Okay, so if we're going to use the same example here, and we're going to denote the domain as the capital letter D, so we can think of here as the domain are the numbers 1, 2, 3, and 4. So we can think of it or write it as follows. Okay, D is equal to 1, 2, 3, 4. In our range, we can denote that as a capital letter R. And then going here again, we can see that our range has the values of 5, 6, 7, and 8. So we have this R equals 5, 6, 7, and 8. So that's the relation, the domain, the range. And I think with this given definitions, we could go to our definition of what we have, what we want to know in this video, that is functions. So a function is actually just a relation in which each member of the domain corresponds to exactly one member of the range. So you can think of it as a special kind of relation actually that restricts something. That is, with every input corresponds to a single unique output. Again, every input must only give us one unique output. So we can think of this as follows. For example, this is our same set, our same relation on the slide before, 1 5 2 6 3 7 4 8. We will ask, is this a function? So how can we think that does this set correspond to the definition above, that every input corresponds to a single unique output? So let's see. We can think of it as this: 1 gives us 5, 2 gives us 6, 3 gives us 7, 4 gives us 8. So does each member of the domain give us exactly one member of the range? Does 1 give us anything but 5? Well, we cannot see it here. Does 2 give us anything but 6? Well, none. 3 only gives us 7. That's unique. 4 only gives us 8. That's unique. So therefore, this example here is indeed a function. Okay, to illustrate one more, let's have one more example. Negative 2, 3, negative 1, 2, negative 2, 0, 1, 2, 2, negative 2. Now, is this a function? So again, to know if this is a function, we need to try to correspond it to the definition above, that each member of the domain only gives us a single unique member of the range. So we can think again as follows. So negative 2 gives us 3, negative 1 gives us 2, negative 2 gives us 0, 1 gives us 2, and positive 2 gives us negative 2. So let's ask ourselves again, does negative 2 only give us 3? Well, we can see it here that negative 2 also gives us 0. So this is a counterexample of not a function. Okay, because it doesn't give us this negative 2 doesn't give us an exactly one member of the range. It gives us two, you see. So this does not correspond to the definition of a function. So therefore, if there is one counter to the definition of the function, this whole relation, this whole set is will be not a function. So it's not a function because it displays some behavior that this input doesn't give us a unique output. Okay, so anyways, just an aside, our previous example here displays a one-to-one correspondence. That is, every domain gives us a unique output in every domain. Okay, here in the second one, this displays a one-to-many correspondence. Um, Here, -2 gives us 3, and -2 gives us 0. So that is a one-to-many correspondence, and one-to-many correspondence is a no-no for a function. Anyways, you can compare it here with -1 to 2 and 1 to +2. The outputs are the same, but the inputs um, are not the same. Okay, so don't confuse yourself here. These are unique um, inputs. Okay, so therefore, -1 gives us 2, +1 gives us 2. So these are unique inputs. So therefore, they're giving us unique outputs. Okay, so -1 gives us only 2. And that's the definition of a function, wherein every domain, every member of the domain gives us a unique output. So -1 only gives us 2. It so happens that +1 also gives us 2, and it's fine. Okay, so meaning this illustrates a many-to-one correspondence. So many-to-one is also okay to a function. But well, of course, there is a there's a display here of one-to-many, so therefore this set will of course be not a function automatically. Okay, so this is it to wrap it up. So we have this lecture. We defined some important definitions for so that we could understand functions. First up, we defined relation. It's any set of ordered pairs, x and y. X is the first component, y is the second component. We defined what a domain is. It's a set of permissible input values of the x that we can input. Um, Next is the range. The range is a set of output values wherein each time you input your x, the range will follow. Okay, so the range is all the set of values of y. And a function is a relation in which each member of the domain corresponds to exactly one member of the range. That is, um, each input corresponds to a single unique output. So that's it, a wrap up for the first of our Simple Algebra 101 videos. We will continue this functions. It's a selected topic since we will be using it soon. So that's why I put it here as a selected topic. So our first video actually is the um, real real number system. So I'll put it somewhere here. Okay, so um, please check it out. Anyways, if you want to see more math videos, we're posting it, math memes, if you like it, kindly see our Facebook page. It's written down here. I'll put it in the descriptions below. And kindly don't forget to subscribe in our channel. Okay, thank you so much.